Today's objective is scientific notation. Scientific notation is a method that the scientists devised, and it's a way to write really, really large numbers or really, really small numbers more efficiently. For example, the distance to a star is 256, I don't even know what this is, million, billion, 256 trillion meters, okay? Or the time for light to travel 1 meter is 0.00000000334 seconds. Okay? That's a really big number. That's a really small number. So it would be easy to leave of a zero. That's good, huh? Look, I made a typo. Leave off a zero. So with scientific notation, we take out the zeros and use powers of 10 instead. Makes it a lot easier. So our 256 trillion.
Eden Alonso, please report to the front office.
He's famous. I'm doing this after school, sorry. 256 trillion in scientific notation would be 2.56 times 10 to the 14. And the 0.000000334 would be 3.34 times 10 to the negative 10. I'll explain how to do it. Now here's our standard form, and here's our scientific notation form. See how this is so much smaller and easier to write? Here are the rules, so you need to write these down. Number 1, you have one digit, the numbers 1 through 9, and then the decimal place. One digit, the decimal point. One digit, the decimal point. You can't write a 0, and you can't write anything bigger than 9 before your decimal point. Number 2, write all the numbers until only zeros are left, and then don't write the zeros. So I wrote 2.56, and then I didn't write all these zeros. I wrote 3.34, and then I didn't write the zeros beforehand. Number 3, count the number of spaces you move the decimal point. It's a negative exponent if it was a decimal to begin with, and a positive exponent if it was a really big number to begin with. So write those rules down, and then we'll do some examples. All right, since scientific notation is a way to write really big or really small numbers, usually measurements, they're always positive. Remember, the negative exponent means the number was really small, not a negative number, okay? So let's write these in scientific notation. I started, but we need to put in what the exponent is. So here's my number, 3,506,000,000, so that's 3 billion. So we go to our first digit, write it down, 3.506, because all the rest are zeros. So 3.506 times 10. Now I need to count how many places I moved the decimal point. The decimal point was here to begin with. So I just count the number of numbers that it moved over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 3.506 times 10 to the 9. Let's do this one. 47 something, 350, 0. 4.735. 4.735. You don't put the decimal point where the comma was. You put it after the first digit, 4 point, and then you write the rest of the numbers until there's only zeros. Times 10, and now we count and see how many we moved the decimal point over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, because we moved it to here, okay? So that's 13 numbers over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How about this one? 2.304018. That's getting to be a little bit annoying that we had to write that many digits. But we did, times 10. Now, we're not going to move it to after the 8. We're still counting because we put the decimal point after the 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those were all pretty big numbers that we wrote in scientific notation. So our exponents were positive. Now we're doing small numbers, so our exponents will be negative. So we just find our first digit after the zeros, and that's where our decimal point goes, then our rest of the digits. So 4.021 times 10, 1, 2, 3, 4, 5, 6, 7. times 10 to the negative 7, because it was a decimal. 3.14. We find our first digit, and then the decimal point goes after that. 1, 2, 3, 4, 5, 6, 7, 8. We moved it over 8 places, so it's the negative 8. 3.0025, because it always goes after the first digit. 1, 2, 3, 4, 5, 6 times 10 to the negative 6. Let's write these in standard form now. It was 3.51 times 10 to the 6th. That means we have to move the decimal point over 6 places. I move it over 2 places for the 5 and the 1. That means the others places are zeros. So if I needed to move it 6, I've already moved it 2. I have to put 4 zeros, and then I go back and put in my commas. Okay? 4.832 times 10 to the negative 7. So this is a negative, so that means it was a decimal to begin with. So if I've moved it 7 places, the negative is actually easier, because if I move it 7 places, this 4 is only going to take up 1 place, so that means I need 6 zeros in front of it. Okay? You could even think of it as 7 if you use the first one as your before your decimal point. 6.334 times 10 to the negative 12. Another negative. Okay, that means I moved it over 12 places. This took 1 place, so I need 11 zeros. Why did I write such a big number? Wow, that was a really small number. How about 8.92 times 10 to the 10? Well, that means I moved my decimal 10 places. These two take up 2 of the places, so I need 8 zeros. And now I'll put in my commas. Sometimes for really small numbers like this, they do 3 zeros and leave a little space just to help them see how small the number is. All right, last bit of stuff. Order from least to greatest. So here I have 2 numbers written in scientific notation and then a number that's written in standard form. So here are the 3 steps. Put everything in scientific notation. Put them in order by the exponents. The larger the exponent, the larger the number. If the exponents are the same, then compare your numbers. So this would be 4.9 times 10 to the 4th. So I have 2 10 to the 4ths and a 10 to the 5th. Well, my 10 to the 5th is going to be the biggest. These are tied, so what's smaller, 3.3 or 4.9? 3.3. So this is my smallest, this is my next one, and here's my largest. Now let's do it with negative exponents. 7.8 times 10 to the negative 3, 7.9 times 10 to the negative 3. Hey, the negative 3's are the same, so compare your digits. What's smaller? 7.8, so it's the smallest one. And then this, so I move it over 4 places. 7.6 times 10 to the 1, 2, 3, negative 4. So negative 4 is smaller than negative 3, so this is my smallest number, then 7.8, then 7.9. Okay, that's pretty easy ordering. Put it in scientific notation. It's much easier than putting it back into standard. Multiplying and dividing with scientific notation. Here are your 3 steps. Multiply or divide your numbers. Add or subtract your powers. Adjust if necessary. So here's example 1. 2.8 times 10 to the 3rd times 4.1 times 10 to the 5th. So this is scientific notation, this is scientific notation. So first I multiply or divide the numbers. So I'm going to multiply 2.8 times 4.1. Did the math, I got 11.48. So I write 11.48, and then I add or subtract the powers. Since it's multiplication, I add the exponents, so 3 and 5 is 8. So my answer is 11.48 times 10 to the 8th. However, I need to adjust because this is not scientific notation. It can't be any bigger than 9. So I need to move over 1 more space and make it 1.148. And if I move it 1 more space, my exponent needs to increase by 1 also. So 1.148 times 10 to the 9th. One thing I haven't mentioned, this is always an X. It's the only time we write an X. No dots, no stars, no parentheses, no whatever. It's always an X, okay? Now let's do a division problem. 1.681 times 10 to the negative 5th divided by 4.1 times 10 to the negative 2. Multiply or divide your numbers. So 1.681 divided by 4 to the 1 equals 0.41. And 10 to the negative 5 divided by 10 to the negative 2. Negative 5 minus negative 2 is negative 5 plus 2. So it's 10 to the negative 3. I'm going to say hi to Howard. Hi, Howard!
Hi.
He's on video now. All right, so here's our answer. 0.41 times 10 to the negative 3. But this is not scientific notation, so we need to adjust it. We need to move one more over. I need to move one more to the right. So it's 4.1 times 10 to the negative 4, because if I moved it one more, I have to increase this exponent one more also. And that's it.